in the form of even and odd. And in the beginning, what we have seen here is that all the fractions or all the rational numbers at some point are irreducible, and they are why they are irreducible, because they cannot have common factor which can divide it even further. For example, we have 6 and 3. So 6 prime factor of 6 is 2 and 3. That's what we have seen. And the prime factor for 3 is 1 and 3. So we have 3 in the both case, that is the both numerator and the denominator. We have 3 as a common factor. So we have to eliminate this common factor, and we are getting 2 over here. Now we have done everything to these fractions over here, and as you can see, we cannot further divide these numbers, and we are getting odd and even number set. Alright, and we cannot even further divide because they don't have any common factors left over here. The only common factor that is left is 1. Now we have another concept, that is what we have already discussed about prime numbers previously. In even and odd case, we can express every number as prime numbers, but there is a uniqueness of prime numbers. That is, if a prime p, we can generalize this, right? So if a prime p can divide a square, this symbol refer divides, all right? It says that p divides a square, means p is dividing a square completely. So the remainder will be equal to 0 over here. P is dividing a square, that implies p also divides a. It is only possible when this p is equal to prime number, and this a should be equal to p, or it should be more than p. But the scenario is that if p is dividing a square, then p must divide a. That is the case, right? Take an example over here, that is we have p is equal to 2 and a is equal to 4. If, for example, 2 is dividing, that is a in this case here is 2 square, that is 4. 2 divides a 4, that is we know that 2 can divide 4 because 4 has the factor of 2 in it, in the prime decomposition. So that implies 2 divides 4, that implies that 2 divides 2, that is 2 divides that is a 2 divide a. A should be equal to 2 over here. There is a mistake that I have 0 over here. It is equal to 2. Alright, so now in the case of composite number, if I take numbers other than prime numbers, p here is not equal to prime, so that means it equal to some other number which we consider as composite numbers, means other than prime numbers. We are considering this p here is equal to 4, and here a is equal to 8. In this case, p divide a square. For example, 4 divides 64, we know that. Alright, and that implies 4 divides 8. So we got the generalization correct over in this situation. But what if I change the numbers from here? That is, if I take p is equal to 4 and a is equal to 2. Now in this case, p is not prime, right? 4 is not a prime number. A we have got equal to 2. P divides a square, but p does not divide a in this situation. That is, 4 divide 2 square, that is 4 divide 4, but 4 cannot divide 2. So we cannot have generalization generalization concept for composite numbers, whereas we can have generalization concept for prime number. There is the uniqueness of prime number. That is, if prime divide a square, then prime divides a. Alright, let's prove. In mathematics, we generally prove the concepts by mostly 2 methods, that is contradiction method, and then we have another method called induction method. In this case, we are using contradiction method. That is, now I am assuming that root 2, I'm considering root 2 over here, right? from out of the irrational numbers, I'm considering root 2. So I'm assuming that root 2 is a rational number. I'm considering it is a rational number. Hence, there exist two integers p and q in the form of p by q. All right. If I'm considering if I'm considering root 2 a rational number, so that means it should belong in a number line, and every number on a number line can be expressed in the form of p by q. And if you reduce it down completely, you're gonna get HCF equal to 1. That is highest common factor of these two numbers is equal to 1. That is 3 and 8 can be divisible only by 1. That is what we have here. That is, every number or fraction on a number line is irreducible when we get different numbers, that is odd and even, in the numerator and the denominator. That is, we are left with the 1 is the only common factor left, which can divide these two type of numbers. All right. So now we are assuming that this 2 is a rational number. So that's why we are considering root 2 have fractional representation, and this fractional representation is at the least form, means it cannot be reduced even further. That means it has 1 is a common factor for that. So we are considering root 2 is equal to p by q. Now, as we know that q should not be equal to 0, and let's say if q is equal to 1 here, we have already seen about q is equal to 0 back. Let's say if q is equal to 1, right? So it will become p is equal to root 2. P is integer, that's what we assume here, but as you can see, p is equal to root 2 is not integer. Root 2 is not equal to p. All right. So actually, root 2 is equal to p, but p is not. P is integer. So this contradicts over here. So q should not be equal to 0, or q should not be equal to 1. Other than it could be any number, right? And the common factor of these two numbers is 1, right? Because it is in the least form. Now we want to remove this square root from here, and whenever we are doing that, whenever we are removing this square root from this side, if I send this to other side, it will give me plus or minus square of these numbers. All right, plus or minus the square of this number. So it doesn't matter, because in this case we are looking for something else. You can see over here, that is, after squaring these two numbers, we are getting 2q square is equal to p square. That is, we have got a number that is p square have factors, prime factors, which consist 2 over here. Prime factors which consist 2 in the primary prime decomposition are considered to be even number, right? So we've got 2 is as a prime, as a factor of one of the number. 2 is a factor of p square, right? So that means 2 is dividing this p square, all right? So that means 2 is dividing p square. That implies 2 divides p. 2 is a prime number, right? So we have seen earlier that this scenario will only applicable for prime numbers. So we can go even further. That is, p is equal to, it could be equal to 2 into k. All right. So we are substituting this p is equal to 2k back in this equation. P is equal to 2k back in this equation here. That is, we are getting, that is 2q square is equal to 2k whole square. That will give me 4k whole square. That is 4k whole square. This 2 and that 4 will get cancelled out. We are going to left with 2 over here. That is, q square is equal to 2k square. Now again we got another number that is from the p by q. That is, q square has the common has a factor of 2 in the primary decomposition. That means, hence, we can say that q is also an even number, and it has a factor of 2 in its primary decomposition. Now, Again, the same thing we can apply over here. 2 divides q square, then 2 divides q is equal to 2c. Hence, we can say that the numerator and the denominator have something which is common, that is even number by even number. But that means, but as we can have taken earlier, that the number that we have taken are irreducible, means we cannot reduce them even further. As you can see, we cannot have numbers even and even over here because we have already reduced them down. So that means they could not have any other number than 1, right? So but we are getting something else here, that is 2, right? So hence, other than 1 we are getting 2 is also the factor. That is what we have taken previously, that is p and q irreducible and 1 is the common factor. We have taken the least form, but as we move on to solve, we are getting 2 as a common factor, that is here, and as well as here we have 2 as a common factor, and again we've got another factor, that is 2 and 1. So hence it contradicts our assumption that root 2 is a rational number. So hence we can say that root 2 does not belong to rational number, it belongs to irrational number. Alright, now I want to highlight something over here, that is, what about numbers like this? Root 3 means a prime number over here. So you can follow the same procedure for the what we did for the root 2. You're gonna get automatically the same result. Okay, so we've got root 3 over here, and similarly we can have all the prime numbers under root, and the explanation will be similar as of root 2. Now we have another type of number, that is prime number under root plus some other number. And you know that when we have a rational number, adding up with some rational number will give you irrational number. That is a basic thing that we have to keep in mind. But what if we have a composite number over here, alright, under root? For example, we have root for a composite number. It can be expressed in the form of root 2 into root 2, that is equal to 2. Alright, we have root, whole root, under, we have 2 into 2. I have separated this root over here. I've got root 2 into root 2, that is equal to 2. We have already seen the explanation for that. Root and root is getting cancelled and we are getting 2. Alright, so 2 is a perfect number, which when squared will give the 4. Alright, so we have another example, that is root 50 can be written as root 2 into root 25, and this is all whole root actually. So we have 2 into 25, right? So 2 into 5 into 5, as we have already seen that in the previous case, that is 5. Root 5 into root 5 will give you 5. Again we got root 2 over here. So that root 2 is irrational, that we have already proved. So hence this root 50 will also be considered as irrational. Now most of the students or people think that we can use the same contradiction method with the composite numbers. Now I'm going to give one example over here, that is, I have root 4. Even though I know that root 4 gives you the value that is equal to 2, and root 4 belongs to integers, and root 4 is a rational number, we already know that. But some people think that by making the same proof of contradiction, we will get that root 4 is also irrational. But today in this video I'm going to clear about this. That is, root 4 is equal to a by b, that is in reduced form. That is, the common factor of a and b is 1. It should not be other than 1. Alright, the numerator should be equal to odd, and the denominator should be equal to even. Either of these case, to be precise, this is reduced form. We cannot reduce it even further. it is irreducible. Now we are squaring on both sides. The same method we are applying over here. We are getting 4b squared is equal to a squared. That is, a squared have the factor that is equal to 4. Alright, so that means a square has a factor of 4. That means 4 divides a square implies 4 divides a. That is a problem that most of the people do. That is, if 4 is dividing a square, that does not imply 4 divide a. As in this case, we have already seen that if 4 is dividing 2 square, that does not imply 4 divides 2. Alright. So this is where we have to stop. All right, we cannot have a generalization for that. This is only applicable only for the prime number. This is the uniqueness of prime, not the uniqueness of composite numbers. So we cannot go further down from this. So hence contradiction, we have to stop over here. So I think I have explained pretty much everything related to root 2. Might left something which you might think that there should be some explanation on that. Please comment down below about it. And I have something more for you. That is, we have numbers having negative root. For example, we are going to negative infinity over here, and we are having all these numbers. As you know that root 2 can be represent somewhere on the number line. All right, it is before, right before 1.5, as we have already seen that. So minus root 5 will also be right before minus 1.5. So we can do the similar with this minus root 3 and minus root 4. What about this type of numbers? Root minus b. Have you seen this type of numbers anywhere, or did we do any explanation for that? This is what we will cover in some other video. Hope we will meet soon, and thank you for watching my video, and please comment down below. If you like my video, please share and subscribe my channel. Thank you very much. Goodbye. See you again.